Hello everyone, welcome to MK Academic Solutions. So in this video, I am going to explain you about the first order reactions. Okay, what is the first order reaction? We'll discuss. It is also one of the important topic in a chemical kinetics chapter. Okay, now let us see what is a first order reaction. So we know first order reaction means here n is equal to 1. So the order of reaction is equal to 1, that is called first order reaction, or the rate of reaction is directly proportional to first power of the concentration. The rate of reaction, the rate of reaction, the rate of reaction is directly proportional, is directly proportional to the concentration to the power 1 is called first order reactions. First order reaction, or else you can define as the sum of powers of concentration terms in the rate equation equal to 1, they are known, that is known as what? First order reaction. Okay, the sum of powers of concentration terms, the sum of powers of concentration terms, powers of concentration terms in rate equation, in rate equation is equal to 1. Okay, such type of reactions are called what? First order reactions. Okay, see, for example, here we are going to take an hypothetical reaction. A is gives rise to product. So here rate is equal to K into A power 1, K into A power 1. So this is the first order reaction. Okay, examples. What are the examples of first order reaction? So you can take microbial growth, or decomposition, microbial decomposition. Next, radioactive decay, radioactive decay in nuclear physics, we can consider it as the first order reaction. And inversion of cane sugar, inversion of cane sugar, inversion of cane sugar, inversion of cane sugar, it is also example of first order reaction. Here sugar formula C12H22O11 is gives rise to, in presence of water H plus, in presence of H2O, it gives glucose and fructose C6H12O6 plus C6H12O6, glucose and fructose it will give. It is the example of what, children? First order reaction. And decomposition of N2O5 also, decomposition of N2O5, 2N2O5 is gives rise to 4NO2 plus O2. Okay, so this is also what example of what? First order reaction. And decomposition of hydrogen peroxide, decomposition, you take that also example of first order reaction. H2O2, 2H2O2 is gives rise to 2H2O plus O2. so etc. So these are the examples of our children first order reaction, and you can take decomposition of ammonium nitrate also. Ammonium nitrate decomposes in the solution state, that is also what example of first order reaction. You can take decomposition of ammonium nitrate, decomposition of ammonium nitrate, NH4NO2. So this is also an example of what first order reaction. So here ammonium nitrate NH4NO2 decomposes as N2 plus 2H2O. So these are all the examples of our children first order reaction. Now let us see the kinetics of first order reaction and rate equation. Okay. So let us take an hypothetical example for first order reaction. So here integrated form of first order reaction, integrated form of first order reaction. Okay. So here observe carefully. So here we are going to take a reactant A, it is giving us a product P. Okay. So let us consider at initial time is equal to 0, the concentration of A is equal to what we are going to consider, small a, or just consider it as the A naught. A naught indicates what? Initial concentration. So this is what? Initial concentration, and at a time t is equal to t, and the concentration of A, it is equal to A. So it will, we are going to take as A minus x. So here A minus x means some of the concentration is decreased here. So it is at time t. Okay. Now in the first order reaction, we already know rate is equal to K into A power 1. Okay. And here what is the rate for this reaction with respect to A? How we can write the rate of this reaction with respect to A? Minus dA by dt, that is equal to K into A power 1. Minus dA by dt is equal to what? K into A power 1. And now let us rearrange this equation, send this A power 1 this side and dt that side. So now dA by A is equal to K dt. Okay. Now let us integrate this equation. Integrate with this equation with respect to concentration and with respect to time. So now here minus integral dA by A. So initial concentration is A, means at initial concentration is A, and at a time t concentration is A minus x. Okay. Right children, that is equal to integral K constant, we cannot do integration. So and here dt. So here t limit is time t is equal to 0, time t is equal to t. These are the limitations here we are going to take. Okay. So now what is the formula of this integration? Minus, okay, minus direct level, right? Minus of ln A minus x minus ln A, that is equal to K t, kt, or simply again 0, limit 0 to t means simply we will get what? Kt. Okay. Now multiply this minus sign into this bracket. So what will get? Minus ln A minus x plus ln A, that is equal to Kt, or simply write ln A minus ln A minus x, that is equal to Kt. So here ln A minus ln B formula you use, it will become as ln become as ln a by a minus x, ln a by a minus x, that is equal to kt. Therefore k is equal to 1 by t ln a by a minus x. So here what is a? Initial concentration a naught, a minus x is concentration at time t. So now you replace them. So here k is equal to 1 by t ln a naught initial concentration by concentration at time t, ln a naught by a. So now instead of ln natural logarithm, you take the log base 10 value. So now it will become as k is equal to 2.303 by t log a naught, means the concentration at initial time, okay, concentration at initial time and concentration at time t, okay, like that graph you like that equation you will get here, okay. This is known as what? Integrated equation of first order reaction. And now let us discuss the exponential form of first order reaction, exponential form of first order reaction, okay. Now let us see exponential form of first order reaction. exponential form of first order reaction, exponential form of first order reaction, okay. So what is the first order differential equation we got here, children? K is equal to 2.303 by t log a naught by a. So now again you write in the ln form. In the ln form, how we are getting? K is equal to 1 by t ln a naught by a, okay. So now you send this t this side, kt is equal to ln a naught minus ln a, okay. Therefore ln a is equal to ln a naught minus kt, okay. So here just what I done here, so ln a I send this side and kt that side, so it will become ln a is equal to ln a naught minus kt. And now remove the ln's. When you remove the ln's, it will become a is equal to a naught into e power minus kt. So this is known as what? Exponential form of, this is known as exponential form of first order reaction, okay. Next let us see the half life of first order reaction, okay. So half life of first order reaction, it is also very important. Half life of first order reaction, okay. Half life of first order reaction. So here what is the meaning of half life, children? What is the meaning of half life? The time required to complete the half of the initial concentration, okay. We know what is half life means, as we discussed earlier. Half life means time required to complete half of initial concentration, initial concentration, that is known as what? Half life of reaction. So here what we are seeing, half life of first order reaction means here T is equal to T half and A is equal to A naught by 2. Okay, concentration at T is equal to what? A naught by 2. Okay, now let us substitute the values here in this equation. Okay, so let us take this equation. Consider this equation. In this equation we are going to substitute. Okay, so now here K is equal to 2.303 by T. In place of T, what I need to write, children? T half, means half of the reaction, means time required to complete the half of the initial concentration. Log, in place of A naught I will write A naught itself, and in place of A what I need to write? A naught by 2. A naught by 2. Okay, so now here A naught will get cancel out, and what will get here, children? K is equal to 2.303 by T 1 by 2 log 2. Okay, so therefore T half is equal to 2.303 by K log 2 value. So here what is the log 2 value? Into 0.3010. This is the log 2 value. So here when you multiply these two, so therefore T half is equal to, when you multiply these two, 0. Just you take it as the 3 itself, 0.23 is 6, 9, okay, 0.69 by K. Okay, you can take up to approximately 0.693. Okay, 0.693, that is the T half, which means, children, T half in the half life of the reaction does not depends on what? Initial concentration. Which type of reactions? In first order reaction. This is the main important point. T half is not at all depend on what? Initial concentration. Which type of reactions? First order reactions. So okay, this is about the equation part in the first order reactions. Next we go to the graphs related to the first order reactions. Okay, what are the graphs here? We will see graphs of first order reaction. See here, we know what is the first order reaction. K is equal to 1 by T ln A naught by A. This is the first equation what we got here. So now here this equation I am going to change as KT is equal to ln A naught minus ln A. Okay, so now ln A is equal to ln A naught, ln A naught minus KT, ln A naught minus KT, like that you will get. Okay, right. So now here, so now let us draw a graph here between ln A and T. So now let us draw this graph between ln A and T, ln A and T. So when you draw a graph between ln A by taking on the y axis, T on the x axis, time on the x axis we are going to take. So now it will become as the y is equal to minus mx plus c, y is equal to minus mx plus c. So here we will get a curve like this. Okay, means this is the c is what? Intercept on the y axis. This is ln A naught. ln A naught is the initial concentration, and here minus m is the slope. So here what is the slope? Here we will get slope is equal to minus k. Slope of this value is equal to minus k. Okay, so this is about the graph between the ln A versus T. Now let us draw the graph between log A versus T. So now let us convert this reaction like that. So now KT is equal to, how we can write now? KT is equal to log, sorry, okay, now we write from first onwards, okay, so that we will get some clarity here. So here k is equal to 1 by t ln a naught by a. So now in place of ln you write the log. So if you want to write the log, we know already we need to multiply with 2.303 by t log a naught by a. So now you send t and 2.303 this side. So what you will get here? kt by 2.303, that is equal to log a naught minus log a. Okay. Therefore, log a you send this side and kt by 2.303 send that side. So therefore, log a is equal to log a naught minus kt by 2.303. Okay. So now let us draw, and again now let us draw graph between log a and time, log a versus time. So it is I am going to take on the y axis, it is I am going to take on the x axis. Okay. So now how we will get the graph? Y is equal to minus mx plus c. Minus mx plus c means here negative slope, here you will get negative slope. So it is the c is the intercept on the y axis, we know this is log a, and here what is the slope? So slope is equal to minus k by 2.303. This is the slope value. And when you draw the graph in the exponential form, let us see the graph in exponential form. Okay. So now we draw that graph in another page. So exponential form. What is the exponential form? Exponential form, we know that is k is equal to 1 by t ln, okay, right. So first k is equal to 1 by t ln a naught by a. Okay. So now we are going to write as kt is equal to ln a naught minus ln a. Okay. So therefore here ln a is equal to ln a naught minus kt. Now remove the ln's here. What you will get here? A is equal to, concentration of A is equal to a naught into e power minus kt. So now draw the graph here. Here y is equal to mx, means it is in the exponential form. So this is the exponential form graph you will get here. Okay. Exponential form graph. So here I am going to take a on the y axis, t on the x axis I am going to take. So now we will get exponent. So this is the parabola like curve you are going to get in the exponential form. Okay. Right. Okay. So this is the exponential form of here concentration versus time for the first order reaction. Now let us see the half life versus concentration. So now let us draw another graph, half life versus concentration. So here t half versus concentration, initial concentration. So t half does not depend on the initial concentration. We know t half does not depend on what? Initial concentration. Okay, we already know t half is equal to 0.693 by k. So here there is no initial concentration term, that's why initial concentration does not depends on, or t half does not depends on what? initial concentration. Okay. So now some important points in the first order reaction. Okay. Let us consider, here we are going to take 100 molecules. These 100 molecules are converting into 50 molecules in time t. So it is looking like what? T half. Okay. So it is a time required for the T half, and again you just consider it as the initial concentration. So from this initial concentration to time required for the conversion of 25 molecules, it is also called what? T half. Okay. And here 25 to 12.5, it is also what? T half. Okay. See here, from here to here, what is the time? What is the time here? It is T 3 by 4th. T 3 by 4th means 3, it is the time required for the completion of T 3 by 4th. Okay. So here T 3 by 4th also we can consider as a time required for the completion of 70%. Here T half we can consider as time required for the completion of 50%. So it is also time required for the completion of 50%. Here also it is the time required for the completion of 50%. So when you observe carefully, here T is 75, not 70 children, here T 75, not 70. Okay. Just made a correction here. Here it is what? T 75%. Okay. So therefore T 75% is equal to, T 75% is equal to how many T halves? 2 T halves. Okay. So this is very important point, and T 99.9% is equal to 10 T halves. So you can make like this, or else here only you can see one more relation from 100 to 75. Okay. 100 to 12.5 you see. So here what is this? This is T 83.5%, means the time required for the completion of T 83.5%. See here how many T halves are required? 3 T halves are required. So therefore T 83.5% is equal to what? 3 T halves. So in this first order reaction. And one more important point here children, that is, in first order reaction, the amount of reactant left after equal time interval forms a geometric progression. Okay. See how it is. Okay. In first order reaction, in first order reaction, the concentration of reactant left, the concentration of reactant left after equal time intervals, after equal time intervals, forms a geometric progression, GP, geometric progression it is going to be formed. For example, see here 100 molecules are converting into 50 molecules. Let us consider within 10 minutes they are going to convert. 50 molecules are again converted into 25 molecules within 10 minutes only, and 25 molecules are converting into 12.5 moles within 10 minutes only, and 12.5 molecules are converting into 6.25 within 10 minutes only. So here what is the concentration here? 100. Here what is the concentration? 100 by 2. Here what is the concentration? 100 by 4. Okay, which means simply what we can take here, 100 by 2 square left. Here what is the concentration left? 100 by 2 cube left. Here what is the concentration left? Here 100 by 2 to the power of 4 left. Okay. So in this manner the first order reaction is going to be complete. So this is what concentration left. Concentration left. So based on this point we can do the number of questions in the JEE Mains. Okay. So sometime in the JEE Mains they will ask questions based on this type of relations only. Okay. So now let us take one example to understand this point. Let us consider a first order reaction. A first order reaction, directly they are telling a first order reaction completes 50% completes. Okay, a first order reaction 50% completes. 50% completes in 30 minutes. In 30 minutes, a first order reaction completes. A first order reaction 50% completes in 30 minutes. And how much concentration? How much concentration left after 2 hours? After 2 hours. This is the question they are asking. Okay. So now how we can solve this? See here 100% to 50%, how much time it is taking? 30 minutes. 50 to 25%, 50 to 25 means it is also one half, this is also 30 minutes. Okay. 25 to 12.5, this also will take 30 minutes. 12.5 to 6.25, this is also 30 minutes. Okay. So means here 30 plus 30, 61 hour, this is also 61 hour, total 2 hours. So how much concentration left? What is the concentration left here? 6.25, 6.25%. Okay. How much concentration left after 2 hours means simply 6.25, or else here how we can take 1 by or 100 by 2 to the power 100 by 2 to the power of 4 you can take simply. Okay, 4 intervals are there, isn't or not? 4 intervals are there means 100 by 2 to the power of 4. It is in the first order reaction. Okay. So here what we discussed in this lecture, children, about first order reaction, complete information about the first order reaction. Okay. So here what is the first order reaction? I explained to you. Okay. What is the meaning of first order reaction? Examples of first order reaction. So these are the very important examples of first order reaction. And then after, integrated form of first order reaction. What is the integrated form? And exponential form of first order reaction, exponential form, and half life of the first order reaction. And next, graphs related to the first order reaction, important graphs. And then after, some important relations in the first order reaction and some calculations here. Okay, important points on calculation. Okay, thank you for watching.